Whenever we use a device to perform an action like browsing the web, maybe making a phone call, or perhaps interacting with our smart home devices, we are exchanging packets of data. Now in our example, we've got end devices that are communicating with internet-based web servers. So we need some kind of access network to support our connectivity to the internet. And that means that on an end-to-end basis, we can exchange these packets of data. In other examples, we might be exchanging packets of data on a much more localized basis where we don't even need to use the internet. But the question is, well, what exactly is a packet of data? Well, what we need to remember is data is just a series of ones and zeros, and we need to get this data from A to B in order to perform a specific role or deliver a specific service. Now, data is often packetized in the network. We need to chop the data up into smaller pieces in order to transport it from A to B. So when we chop that data up and we create a packet of data, what exactly is it? Well, if you were to look at a packet of data, fundamentally, it's got to have addressing on it. The addressing will ensure that that data will get to its ultimate destination, but also when it arrives at its destination, we'll know where the data's come from so that we can reply. So there'll always be addressing on our packet, and what we might see are additional optional features on our packet. We might see features related to making this packet more secure, or making the delivery of the packet more reliable, or ensuring that this particular packet takes a particular route through the network. Now, these elements are considered to be packet overheads because it's not the actual data that we're trying to transmit. This is still ones and zeros, but it's ones and zeros related to actually transporting the payload. And the payload is the actual content that we're interested in, whether it's a piece of voice, a piece of video, some web information, or sometimes signaling information related to maybe setting up the phone call or setting up the video stream that we might be wanting to watch. So when we look at a packet, we do need to consider the overall composition of the packet. We don't want to have too much overhead versus the actual payload content itself, because then it won't be very efficient to transport these packets. But if you're looking at something like a Netflix video stream, then within the space of just 1 minute of video, we will see hundreds of thousands of these packets arriving at the end device. So if you scale that up to consider all the different use cases and users of our networks, you can imagine just what scale of packet delivery needs to be managed by our networks on a second by second, minute by minute basis.